now we have a jetliner that lands at a speed of 160 miles per hour. Okay, so here we've got V is equal to 160 miles per hour when it lands. Okay. And it decelerates at a rate of 4.47 meters per second. Now, this plane is going to travel at this constant speed of 160 miles per hour for 1 second after landing before applying the brakes. Okay, and then after that, we're going to be asked, what is the total displacement of the aircraft between touchdown here at point A on the runway and coming to rest down here at point C? Okay, so we have two parts of our problem that we're going to work through. We've got the airplane that lands and it travels at a constant speed, which means no acceleration for 1 second, and that's up here to point B. And then after point B, it's going to apply its brakes and come to a rest. Okay, and in order to find this total distance between point A landing and point C coming to rest, we're going to have to break this problem up into two portions, portion A to B and then portion B to C. Okay, so our final thing that we're trying to solve for is this total displacement, or this total distance that the plane travels. Okay, so we're going to call that distance A to C. All right, now let's go back and fill in some of these knowns and unknowns that we have. So I've already drawn out my little diagram here. So we're landing at our speed of 160 miles per hour. We're going to travel at that constant speed. So here at point B, I also still have my speed of 160 miles per hour. And the time it takes to go this distance is 1 second. Okay, so because of this velocity remaining constant, that means that we have no acceleration during that segment. Okay, and then between points B and C, that is when we're going to do our deceleration. So the final velocity at point C is going to come to rest, so that final velocity is 0 meters per second. And so we know that this acceleration during our slowdown phase, our braking phase, we'll call this part braking, is that deceleration is minus 4.47 meters per second squared. So the problem is going to say it decelerates at a rate of 4.47 meters per second squared. That term deceleration means I've got to put a minus sign in there whenever I'm solving this problem. Okay. All right. Now we've got to find the total displacement between points A and point C. All right. So we're going to break it up into two parts. As I said, we're going to start by working to figure out what is the total distance that we travel between points A and B first. Okay, so we're going to figure out what is our distance A to B. Now to do that, we're going to use, look at our equation sheet and use one of those equations off of there. An equation for which the unknown is the distance, and the other knowns are going to be our velocities in the problem, the time we travel, the acceleration. Also, let's say we start at point A here. We're going to say our initial position, we're just going to call that 0 meters. Okay, so if we look at our equation sheet, we've got an equation that is x is equal to 1/2, this is our final position x, or our distance over here at point B, so maybe I'll call that x sub b, is equal to 1/2 at squared plus our initial velocity of this segment times time plus our initial position for this segment. So we already said that that initial position is going to be 0, okay? Our initial velocity, that's our 160 miles per hour. We know the time, 1 second. Our acceleration is 0 because we're traveling at constant speed during this time. So our acceleration here is 0, so that means this first term here is going to be 0, because when you multiply 0 by these other two terms, that's still 0. So our position at point B, or that would be the total distance we travel between A and B, is going to be equal to V0t. That's it, just equal to V0 times t. Okay, so our t is given in seconds. Our initial velocity here was given to us in miles per hour, okay? But we don't want to use this velocity in miles per hour, okay? We've got an acceleration that we're going to encounter later in meters per second squared. And in physics, generally, we want to work out most of our problems in SI units. So I'm going to go ahead and convert my 160 miles per hour into meters per second. So let's do that right here. If we've got 160 miles per hour, okay, we're going to multiply this by two conversion factors. One that gets us from hours to seconds, and another one that gets us from miles to meters. So let's start with our time conversion factor first. So I know that in 1 hour, there's 3,600 seconds. Okay, so that gets rid of my hour unit and leaves me with my seconds unit. And then in 1 mile, there is 1,609.3 meters. All right, so that's not something that I would expect you to memorize. Maybe that would be something I would give to you on an exam, or if it's in part of your homework problem, maybe you're going to want to look that up somewhere on the internet, or maybe you can find a conversion chart in your textbook. Okay, so my mile units, I've gotten rid of that, and I'm left with meters on top, seconds on bottom. All right, so if I take 160 times 1,609.3 and divide it by 3,600, I'm going to get my speed in meters per second. So if you do that, then you'll find that this speed is 71.5 meters per second. Okay, so 160 miles per hour, 71.5 meters per second. So that's the speed I'm going to use here in my equation for the distance that I travel between point A and B. That's equal to my initial speed, 71.5 meters per second, times time. 1 second. Okay, that was easy. So the distance I traveled during this first segment at constant speed is 71.5 meters. Okay. I'll call that XA to B. All right. Now let's deal with finding that distance between points B and C that we travel. Okay. So distance between point B and C. Well, let's look to see what we know here. We've got an initial velocity, we've got a final velocity. This time, there's an acceleration in our problem. We don't know how many seconds it's taking us to do this. So we look back at our equation sheet and look to see what equation can we use that incorporates all the knowns that we know for this segment, and that leaves us with one final unknown, which is going to be our distance that we need. So one of those equations that we could use is this one right here. Okay, our final velocity squared minus our initial velocity squared for this segment equals 2 times the acceleration times our final position minus our initial position. And so we're thinking about just this segment here, parts B to C. So let's look here. We see we can go ahead and get rid of a few terms. My final velocity, that's this quantity here, v squared. That final velocity when I reach point C is going to be 0. So this term here is 0. Okay. Now this term that I wrote, the v sub 0 squared, that's our initial speed for this segment BC, which would be our 160 miles per hour, or 71.5 meters per second. Okay. Our acceleration, that's this minus 4.47 meters per second squared. Now for this segment too, we can also say that our initial position here is going to be 0. Our final position would be this distance between here, B, to point here at C. Okay, so I can say that my initial position for segment BC is going to be 0. Now, I'm going to actually, before I fill this in with numbers, I'm going to solve this algebraically for x right here. That's our final position. That's our position here at point C. Okay, so we've got minus v0 squared equals 2ax, and I'm going to call this x bc. Okay, and so I solve this for x bc. So x bc is equal to minus v naught squared over 2a. Okay, so that's going to be equal to minus, for this segment, our initial velocity at point B was 71.5 meters per second. We're going to square that, and we're going to divide it by 2 times the acceleration, minus 4.47 meters per second squared. Okay, so I've got negative, okay, that's outside the parentheses. I'm going to square this quantity here, 71.5 meters per second, and divide it by 2 times minus 4.47 meters per second squared. So we've got a negative quantity on top, a negative quantity on bottom, negative divided by a negative, that's going to give us a positive value. Plug those in, and I get that this total distance for to travel from B to C is going to be 572 meters. So that's XBC. Okay. So then my total distance AC, from point A to C as we're coming to rest in this problem, is going to be my distance AB plus my distance BC. So that's going to be our 71.5 meters plus our 572 meters. Okay, so then that's going to give us 643.5 meters for our final answer. And that is the total displacement of our aircraft between touchdown on the runway and coming to rest.